Hey everyone, welcome back. In this video we're going to continue talking about the topic that we started a couple of videos ago, which was algebra. Now in the first video it was just sort of an intro to what sets algebra apart from the math that we've been doing before and why it's useful to have letters represent unknown quantities. Remember that we call those letters variables. And then in the last video we started seeing how variables sort of come into play in a few different types of questions. Now in this video we're going to go through just a few simple practice problems. There's not really going to be a whole lot of multiplication and division involved in these ones. Right now it'll just be some practice problems involving addition and subtraction. But we'll eventually expand that idea to bigger and better things. But for now, we'll leave it the way it is, just because once you start incorporating multiplication and division into it, it'll either get too complicated for what I want us to be doing right now, or it'll be so simple that it'll be basically no harder than the examples that we saw at the end of the last video. So for now we'll just stick to a few practice problems involving addition and subtraction, and then we'll eventually come back to some harder problems in the next few videos. So this video and the next couple of videos, we won't really be covering any new topics. The problems themselves will just be getting slightly harder every time. So in this one we're just going to go through a few simple examples of problems that are sort of more focused on addition and subtraction, and then later on we'll get into some more complicated ones. Now I don't want to get into anything too complicated yet, because some of the more complex stuff involving algebra is stuff that we kind of need the later units for, like when we talk about linear functions and quadratics and what all of these different equations mean. That's something that we'll end up talking about more as the units come and go. So yeah, we'll start without me babbling too much this time. We'll just go through a few simple examples. This one might not be that long of a lesson, but it's just for you to get a bit of a feel for how these problems work, and then we'll up the ante next time and do something a little bit harder. So we'll start this one with a problem like, let's go with this one. I have 3 problems written out here. This might take all of 10 minutes to get through, but I'm going to highlight a few points as we go, and then we'll see if there's anything else that I can think of before I let you guys go. But otherwise it'll just be these 3 practice problems for this one. So we'll start with this one. Sure, the numbers are slightly large, but in terms of making use of the concepts that we sort of established in the last video with how the addition and subtraction and stuff works, this is perhaps the simplest problem. All of them are fairly simple, but this one is slightly easier than the other 2, and you'll see what I mean a little bit later on. So remember what I said last time. When you start with this problem, you've got some terms. So this thing here, even if you've got the 2 things being multiplied together, this entire thing is one term. So these terms are separated by addition and subtraction signs. I mean, right now we've only got addition here, but so we've got our first term over here, our second term there, our third term over there, and then the 57 is by itself on the other side. But so notice that this first term has a variable in it, right? And this third term over here, this 6x, also has a variable in it. So the important thing that you have to watch out for when you're adding and subtracting is that you can only add and subtract numbers with numbers and terms that have variables with terms that have variables. And it's a little bit more specific than that. If you had, when we get into some more complicated stuff, you'll see that we might have some terms that have x, some terms that have x squared, some terms that have maybe when we get into using two variables, we'll have some terms that have an x, some that have a y, some that have x times y. So you can only add and subtract terms that have the same types of variables as well. So if we had like, this is like a bit of a side note, so if you had like x plus x squared, we can't add those two terms together. But if you had x plus x squared plus 3x, then this x squared doesn't have the right type of variable to be added to the other things. But this term has just an x as its variable, and this term has just an x as its variable. It's multiplied by 3, sure, but the variable itself is just an x, and the variable over here is just an x. So those two terms could be added together, and this x squared would have to stay by itself. So if we take that idea to the context of what we've got in this problem, this first term has an x as its variable, this second term has no variable, this third term has an x as its variable, and this thing has no variables whatsoever. So we've got two different types of terms here. One is that it has an x, so the term has an x somewhere inside of it, no x squared, no x cubed, no y, just a single x. And the other one has no variables at all. So we've got those two types of terms in this problem here. So we've got two terms, this one here, this 20x, and this 6x, both have a single x inside the term. So we've got 20, you could even think of it as physical x's, think of it as like a block with an x written on it. We've got 20 of those over here, and we've got 6 of those over there. So those blocks could be added together, but those blocks aren't the same as the block that has, I don't know, the number 5 on it, and the block that has the number 57 on it. Those can't be added into the same group as the 20x's over here and the 6x's over there. So we need to split this up. I'm going to get rid of some of the things I've written on these boxes around here. But basically the thing we want to notice from the setup here is that this first term, this 20x, has a variable in it, but that 6x, and the 6x over here also has a variable in it, but the 5 and the 57 have no variables in them whatsoever. So when it comes to adding and subtracting, this term here and this term here could be added or subtracted from one another, and this term here and this term here could be added and subtracted from one another, but nothing else. You can't do 20x plus 5 and just get an answer, unless you know what x is, but then you wouldn't have any variables because you know what x is. It would just be full of numbers. Anyway, we'll come back to that. Basically, you can only add together terms that have the same types of variables in them. So we've got two types here, one with an x and one with no variables whatsoever. So what I'm going to do is I'm just going to ever so slightly rearrange this first line, and I'm just going to stick the 20x and the 6x side by side. I'm going to put them next to one another. So then we're going to have 20x plus 6x plus 5 is equal to 57. So now we've got these two terms that have x's side by side. I'm going to get rid of this these two types down here as well now. So we've got 20x plus 6x plus 5 equals 57. Now remember, the goal of this question is to figure out what x is equal to. So the goal of this question, I've given you this equation at the beginning. Our target is to figure out what does x have to be equal to in order for this to be true. Or basically, what does x have to be equal to make sure that this side of the equation is actually equal to 57. If x is 0, it's not going to work. If x is 10, it's not going to work. What value of x must be put in place of the letter x here? 20 times what plus 5 plus 6 times what is going to equal 57. That's the question that we're trying to figure out, is what is that magic number x that makes this entire thing equal to 57 that we have over there. So we haven't really tackled that problem yet. All we've done is rearrange the setup a little bit. So now what I'm going to do is we have 20 x's. So you could even think of this as, like I was saying, you could think of it as like a little as a little block with an x on it. And so you have 20 of those blocks here, and then you've got 6 more of those blocks here. So we can just add together the number of blocks with x's on them. So we've got 20 of those blocks here and 6 of those blocks there. So if we add these two together, we just add the numbers together and we leave the x alone. So we had 20 x's to start and 6 x's over there. So when we add those together, we'll get 26x. That's what we get from adding these two terms together. So 20x plus 6x is going to give us 26x. You could think of x as, like of the x in the equation as like an object. I was saying this before. You could think of it as like apples, or like I was just saying now, blocks with an X written on it. But if that's a little too obscure, just think of it as something like apples or bananas or something like that. You started with 20 bananas, you're adding 6 bananas to it, you have 26 bananas. Don't think too hard about the fact that this X is actually representing a number. But anyway, so we add those together. We've dealt with the 20x and the 6x, and that's given us 26x. Now for now, I'm just going to rewrite what we had over here. So we had 26x plus 5 equals 57. Alright, so I'm just rewriting those two bits once again. Now, if you remember what I said, when we're solving a problem like this, when we're trying to figure out what x is equal to, I'm going to have to get rid of my title here, we want all of, it's almost like if you put an imaginary line down the middle, on one side we want all the terms that have the variable. So in this case we're only working with a single variable. It's not like x squared or x cubed or anything like that. So we've just got a couple terms with x and a couple terms with no variable whatsoever. So we want all the terms with a variable to be on one side of the equal sign, and we want all the numbers, you could say, all the terms that have no variables, to be on the other side. Now you could have a number attached to a variable, so something like this 26x. This is a term that includes a variable, so we want it to be on one side of the equation, but this 5 and that 57 don't include any variables whatsoever. So we want those to be on the other side of the equal sign. Now the equal sign is right here, so the 57 is already on the opposite side of the equal sign. The problem is this 5 over here. This 5 is on the same side as the term with a variable. So the easiest thing for us to do if we want to separate the terms with variables from the terms without variables would be to take this 5 and chuck it over on that side. Now the way we can do that, there's again the two ways that we were talking about before, two ways that you can think of this. One way is to subtract 5 from both sides. So from the left side we had 26x plus 5 minus 5. So we just throw in a minus 5 over here, and we throw in a minus 5 over there. And then if we simplify that, I'm going to run out of space down here, so I'm going to move this up to the top. I'm going to get rid of that little thing there. So if we're subtracting 5 from both sides, then this plus 5 and this minus 5 will cancel each other out. We have a plus 5 here, and that's going to cancel out with this minus 5 over here. So that's going to leave us with just 26x on the left side. And then on the right side, we've got 57 minus 5, which is 52. So on the right side, we've just done this subtraction here. This 57 minus 5 gave us 52. And over here, we had 26x, and then we added 5 to it, and then removed 5 from it. So those two just cancel each other out, and we're left with the 26x over here at the front. Now again, the other way that you could think about it is if I write this slightly differently. Then we had our 26x plus 5, right? We had our 26x plus 5 over there, and we had just our 57 over on the other side, right? We had just 57 over there. Now the way I sort of tend to think about this is I want to take this 5 and throw it on the other side of the equal sign. So I'm going to throw that 5 over there. So it's no longer over here. So I'm getting rid of that 5 from this side. It's now over there. It was being added on the left side. So when I take it over to the other side of the equal sign, I'm going to switch the operation. So if we were adding on this side, we're going to be subtracting on that side. So that means that this whole 57, this whole 5 and the plus sign is gone from here, so we're left with just 26x, which is what we have up here. And then on that side we have 57 minus 5, which is 52, which is what we got over there. So this gets us very close to the end of the problem. And I'm going to just erase this next line just so that you can see where we're working. It's going to be directly below this. Now we don't want the 26 to be attached to this x. I didn't ask what's x multiplied by 26 equal to. I want to know what x is equal to. So I don't want it to be multiplied by 26. So to undo this multiplication by 26, I'm going to divide by 26. But if I'm dividing by 26 on this side, then I also have to divide by 26 on that side. So if I've got x times 26 divided by 26, that means that the two 26's are going to cancel out, and I'm going to be left with just x on the left side. And then on the right side, 52 divided by 26 actually turns out to work out quite nicely to equal just 2. So that would be how you get your final answer for this one. Now, how do we know if we have the right answer? A good way to check that you have the right answer is, we'll go back to the original equation, so I'm going to get rid of what we had down here, and I'm going to rewrite the original equation. So we started with, in the question, we started with, if I put a little squiggly line here so you can see where we're starting. So we had 20x plus 5 plus 6x is equal to 57. That was the question that we started with. Now, if x equals 2 is the right answer, then I should be able to replace these x's here with the number 2, and I should get 57 on this side and 57 on that side. So I should basically get the same number on the left and the right side if I put in a number 2 where I have these x's over here. So let's go ahead and do that. So in the next line, I'm going to write down the multiplication the last way I showed you, which is using brackets or parentheses. So we've got 20 times 2. 2 is coming from our answer. We want to check if that's going to give us the right answer. Plus 5 plus 6 times 2 is equal to 57. Alright, so that's what we want to see is, there are a couple of different ways you could go about this. If you wanted to still move the 5 over there and do the subtraction, that's fine. We don't care if both sides are like 57 is a nice target number for this question because we don't have to do any work on that side to get it down to a single number. It already is a single number. But basically the left side and the right side just need to equal the same number. So if I got rid of the 5 from this side, I'd be subtracting it over there, so that would become a 52. And then I would want my remaining terms to add to equal 52. So if that's confusing, don't worry about it. Basically, the idea is we just want the left side and the right side to equal each other, but it doesn't matter if they're specifically the number 57, even in a question like this one. So let's just go ahead and do that multiplication and see what we get. Here, 20 times 2 is going to give us 40. So that's 40, and then we've got plus 5, and then we've got 6 times 2 is 12. So we've got plus 12 there, is equal to 57. And I'm sort of running out of space, but if you add these together, 40 plus 5 is 45, plus 12 is going to give us indeed 57. So we got 57 on the left side, and we got 57 on the right side. So that's just our quick way to check our final answer, is to plug that value back into the original equation and see if the two sides are actually equal to one another. Alright, so that's the way we can solve for x. So that's what we spent most of this time doing, and then going back and checking our answer. Now let's approach a very similar problem. It's got one ever so slightly harder component to it, which is, so in this first problem, we had all the variables were on one side, and the numbers were slightly mixed up with numbers on both sides. In the second problem, we're going to have variables on both sides and numbers on both sides. So we've got 4x plus 8. This is a new problem, so if you want, you could title this as like a new example. 4x plus 8 is equal to 6x plus 2. Alright, 4x plus 8 is equal to 6x plus 2. Now remember, we want all the variables on one side and all the constants, all the numbers, you could say, on the other side. So what I could do is I could bring the 6x over here if I wanted to, but then I would be subtracting, because right here it's a positive 6x. So if I'm bringing it over to this side, it's going to become a negative 6x. But that means I'm going to be doing 4x minus 6x, which is going to give me a negative answer, right? It's going to give me negative 2x. I don't know about you. You could be fine with dealing with negatives. I personally would like to avoid negatives wherever possible. So instead of bringing the 6x over here and making everything negative, I'm going to instead take my 4x and I'm going to chuck it over to that side. Alright, because I want all the terms with x's to be on the same side. So here it's a positive 4x, so when I throw it onto that side, it's going to become a negative 4x. So I could write my next line as, if I'm getting rid of the 4x from here, I'm going to just be left with having an 8 on this side. And then on that side, I'm going to have 6x plus 2 minus 4x, right? The other way you could think about it is to get rid of the 4x from this side, I'm going to subtract 4x from the left side. But if I'm subtracting 4x from here, I have to subtract 4x from there, and that should still give you this line here. You should have just the 8 on this side, and then you should have 6x plus 2 minus 4x on that side. Now we've got all the terms with variables on one side of the equation. It doesn't matter if it's the left side or the right side, so this time it happens to be on the right side. And we've got 6x minus 4x, no problem, we can solve for that. But this pesky 2 is mixed in with that. We don't want the numbers to be on the same side as the terms with variables. So I'm going to take that plus 2, I'm going to chuck it over to this side, and so because it was being added on that side, it'll be subtracted when it comes over here. So I'm going to end up with 8 minus 2 on the left side is equal to 6x minus 4x on the right side. And if I go ahead and I do that subtraction, 8 minus 2 is going to give me 6. 6x minus 4x is going to give me 2x. And so basically now we're just asking ourselves, what number do I have to multiply 2 by to get to 6? So that's fairly simple. I'm not going to erase the whole board just for that final answer, so I'll just squeeze it in here for now. And then maybe I'll erase this and sort of go about it a slightly different way. We'll solve it a second way, actually. So yeah, I'm going to leave the question there, and then we'll solve it a second way and see if we get the same answer. So here we're asking ourselves, what do we have to multiply 2 by? So here's our what, here's that variable. What are we multiplying 2 by to get an answer of 6? So that's going to give us x is equal to 3. The other way you could get that is by dividing both of these sides by 2. 2x divided by 2, the 2's will cancel and I'd be left with just an x over here. And on this side it would be 6 divided by 2, which is 3. Now, I'm going to erase the solution that we just did. So like pause it if you need to write that down. But we're going to do it a slightly different way and see if we get the same answer. So let's say you don't mind working with negatives and you like having the variables on the left side. So let's say you didn't enjoy very much that I did 6x minus 4x on the right side, and you would have preferred if I did 4x minus 6x on the left side. So let's do it that way, and I'll just show you that it should still give you the same answer. So if we go ahead and do that, we'll pull the 6x over to the left side, so it'll become 4x plus 8 is what we started with, minus 6x is equal to 2. Alright, so that's what we've got here, is that we've got 4x plus 8, that's what we started with on the left side. We've taken this positive 6x and brought it over to the left side. So now, because it was positive before and we've brought it over the equal sign, it becomes negative now, so it's being subtracted here. So we've got 4x plus 8 minus 6x is equal to 2. Now I still don't want this 8 to be in the middle of my terms with variables, so I'm going to take this positive 8, it's positive because it was being added over here, I'm going to take this positive 8 and I'm going to chuck it over to that side. So I'm going to be left with just 4x minus 6x on the left side, and I'm going to get positive 2 minus 8 on the other side. Alright, so now this looks somewhat different from what we had before. So let's see that this does give us the same answer. 4x minus 6x is going to give us negative 2x, which is equal to 2 minus 8, which is actually going to give us negative 6. So now this looks a bit more similar to what we had before. Now I don't want x multiplied by negative 2, I want just x. So to get rid of the negative 2, I'm going to divide by negative 2 on this side. I'm going to divide by negative 2 on that side as well, because if I've done it to the left side, I have to do it to the right side. So over here, this negative 2 and this negative 2 will cancel each other out. So I'm going to be left with just an x on the left side. But then on the right side, I've got negative 6 over negative 2. Now the negatives will cancel each other out. A negative divided by a negative is a positive. So those two negatives are going to cancel each other out. And I'm left with 6 divided by 2, which is 3, which matches the answer that we got over there. Alright, so those are two slightly different ways to approach the problem, and you can see that it gets you the same answer regardless of how you choose to do it. So feel free to do it in whatever way makes you most comfortable. And I'll leave it as something for you guys to try, is just go back and plug in x equals 3 into these two spots for the 4x and the 6x. Plug in 3 in place of the x's and see if you can get both of those sides to equal one another. Alright, so we'll leave that one there. Hopefully you guys don't struggle in trying to show that those two are indeed equal to each other when x is equal to 3. Here we would get, you should get something like 20 equals 20 if you go ahead and plug that in. So see if you get that. But what we're going to do now, we'll do one last example and then I'll let you guys go. This one is, again, it's not really harder. I've just added a couple more terms and some subtraction mixed in with addition. But it's the same sort of level of complexity as the one we just did. So we've got 16 minus 2 plus 3x minus x is equal to x plus 17. So a whole bunch of terms this time. So more terms than we've been dealing with thus far. So what I'm going to start with right off the bat is I've got two numbers on this side and I've got two terms with variables on the same side. So over here I'm going to just deal with this subtraction. Numbers minus numbers, I can do that. 16 minus 2 is going to give me 14, right? No problems there. 3x minus x, that's like 3 bananas minus 1 banana, is going to leave me with 2 bananas, or 2x in this case, right? So we've got 14 plus 2x on the left side is equal to x plus 17 on the right side. Alright, so now at least we've got it down to one term with variables and one term with numbers on each side. Now I'm going to bring this x over because I want the terms with x's to be on the same side, and preferably I'd like for it to be a positive number, so I would rather do 2x minus that x than have to do x minus this 2x. So I'm going to bring the smaller quantity over the equal sign and make that one negative instead of the larger one. So that means I'm going to have 14 plus 2x minus x is equal to 17. But I don't want this pesky 14 to be mixed in with my terms that have variables. So I'm going to take this 14 and chuck it over on that side. So I'm left with 2x minus x on this side, which we could have solved that right away, is equal to, we had 17 already. This was a positive 14 on this side, so when I take it over to the other side of the equal sign, it'll be negative, so it'll be 17 minus 14. And so then we can just go ahead and we'll do the last step. We've got 2x minus x is going to leave us with just x on the left side, and 17 minus 14 on the other side is going to be just 3. So hopefully nothing too surprising there. I know I went through this one a little bit more quickly than the first two, but because it's sort of the same idea, I figured we should up the pace just a little bit so you guys can get a feel for this type of problem. But what I will do, because I've gone through this one a little bit more quickly, is I will take the time to check that x equals 3 is indeed the right answer. So what we'll do is we will go back to the original equation, which is what we have up here, and we'll just plug in a 3 everywhere that we have an x, and we'll go and see if that gives us the right answer. So when I was working this out before, I got a 3 then as well, so that's a good sign. And let's see if we get a 3 now. Alright, so we know x equals 3. I should have actually left that on the board. I'll just make a note of that in the corner. So we've got x equals 3. Alright, so up here, 16 I don't have to change. The negative 2 or the minus 2 that I'm subtracting there I don't have to change. Here I have to make a little bit of a change because now we have to actually sub in that x equals 3. So this is 3x, that means it's going to be 3 times 3. And then we've got minus x, which is just 3. Alright, so that's the left side. 16 minus 2 plus 3 times 3 minus 3 is equal to x, well x is equal to 3 plus 17. Well, we know that right side, 3 plus 17 is 20, so, oh, this is looking like the last one, that it should be 20 equals 20 again. But so that side is 20, so that's our target. 16 minus 2, dealing with these two terms, that's 14, plus 3 times 3 is 9, minus 3 is supposed to equal 20. Let's see if it does. 14 plus 9 is going to give us 23, minus 3 is 20, and yes, 23 minus 3 is indeed going to leave us with 20 equals 20. So because we've got the same number on both sides here, note that the 20 that we got here when we were checking our answer, 20 doesn't show up anywhere in the question that we started with, and it doesn't even show up in this side of the solution up until that very last step. So that just goes to show that it doesn't have to equal a specific number, it's just the left side and the right side have to equal each other. That's all that matters. So hopefully this problem makes sense. Hopefully I didn't speed through this last one too fast, but I figured I took it slowly enough in the first couple ones that that I'll try and speed through this one. So if you understood this last one at a bit of a faster pace, and even though we had more terms and stuff inside of it, then hopefully you've got a pretty good grasp of this. I think I'm recording this at the time that you guys have your week off school, so you'll probably be seeing this well into the future relative to the time of recording, but this was originally scheduled to be a video for you guys to watch on a Friday right before the weekend, so that means that it should ideally give you a couple of days to sort of digest this material. If you happen to not be watching it on a Friday and you've got another lesson tomorrow and any of this isn't making sense, get in touch with me as soon as possible so we can clarify those doubts, and then next video we'll keep talking about a similar idea, but we'll make the problems a little bit more complicated. And I'm trying to decide if I want to throw in some sort of word problems so that you can sort of see an application for this stuff, use of this stuff in the real world. But we will get to the word problems. I just don't know if it'll be in the next video or the one or two after that. But yeah, if you guys have any questions, get in touch with me. Otherwise, I will see you in the next video. Have a good one.